Hello and welcome back to the lab. Today on the bench, I got a delivery that I've been waiting on for quite some time. I ordered this at the same time that I ordered the DC load in the DC load and power supply breaking video. It's taken that long to be delivered, but I ordered a 2281S, the low noise power supply and battery simulator from Keithley. Full disclosure, there are no sponsors to the channel. I gave them a credit card. They sent this to me. So, this is gear that I'm picking for my own lab. My wife actually has a bunch of projects that I'm going to need to do some battery simulation on. I also have to work on batteries for this guy. Didn't know this had batteries in it until I got a comment from somebody letting me know. Yep, my batteries are toast, and I need to replace them. So we're going to see about what kind of load this is, see if I can get some higher capacity batteries. Anybody who's grabbing one of these peak-to-peak detectors from Tektronix, there's the number. Tech advises that the batteries be changed out in here annually. So I'm going to see if we can't find something to get that taken care of. I got some other neat stuff that's being delivered this week as well. And I'll be doing some videos on those. I'm not going to spoil it in this video, but I really hope it, one of the things that I have coming works. If it does, that is going to push us much higher in the frequency domain of the lab, and give me a way to calibrate the 284s. So we'll see what happens there. This is for playing with batteries, and it's also a nice supply. I've got the 7510 warming up. It's going to be a while yet because I just turned it on. So we'll check some of the noise figures of the power supply, and we'll check some of the noise figures with it loaded. This thing is heavy. Like, this is super heavy. It doesn't look like it from the package, but I'm not going to open it up because it's a brand new unit. But I'm guessing there's a toroid in there that's about yay big. There's a lot of weight concentrated in this area, and I can see toroid through the side. So this is a linear power supply, so it's not a switch mode, but I was really surprised when I took this out of the box, and I was really surprised when the box came in. I had to unbox this before I started shooting this video. Box wouldn't even fit on the bench. It was huge. Packing material was massive in there, so there's no surprise why it arrived safe. Normally, on the channel, you guys see everything when I do. I don't do any prep work for the videos. I don't script the videos. I don't do anything like that. So you guys are discovering this as I am. In this case, I have read the manual. Since this is a brand new unit, wanted to know what I was doing. So I have read the manual on this one. Normally, I don't even read the manual before I turn the camera on. That is sometimes why my videos can be kind of disjointed, because I'm discovering these things live while the camera's rolling. It is what it is. So, front of the unit, this does not have a touch screen. So, soft button at the bottom and full keypad on the side. Comes with this cover, I guess, is what we'll call it. I'll get into that here in a little bit. Let me flip this around. This thing is extremely heavy for its size. So on the back, we are in a 120 volt country. Power, we have USB and Ethernet. I'll be hooking up the Ethernet as well. I'm working on setting up some data logging, and I'm also working with a couple of people on the EEV blog. I got to get some Raspberry Pis set up in the lab. He and I are talking about using some of my Keithley gear as his test bed so we can get some of the Keithley gear logging, because I've liked the form factor of the meter. The 6500 is my daily driver for the bench work. I do have a Fluke 179. That's my daily driver for out of lab on site work. But especially now that we have this power supply in the lab, I need to get some longer term testing running. stability testing, things like that. I need to add, and I also need to get some noise under control in a lab. This does not have a cal due date on the cal sticker, so I don't know if this just doesn't need a calibration or if it shouldn't be checked. I need to do a little bit more digging on there. It is a power supply, so I'd say unless it's grossly off, probably not. I mean, I can always check it with a 7510. Fan in the back for cooling. GPIB, that's another thing that I want to get up and running and off the ground in a lab, is get some GPIB going. A couple of the goals for the GPIB would be to be able to pull a waveform off the 7854 and do some data logging for some of my other instruments. I'll use LAN when I can because the data rates are just faster. I've got 10 meg here, I've got a gig here. Everything in the lab's gigabit Ethernet. So if that's something that's interesting to everyone, or anybody has questions on more of the back end stuff in the lab, let me know. I know it's not as fun as test gear or doing design or actually getting stuff built, but it is necessary. Very important. This Phoenix connector in the back. This needs to be installed, and it should come out. Maybe not. Yeah, that is a Phoenix connector, so it should pop out, but I'll have to pull straight. These are the sense terminals. There's no sense terminals on the front of the unit. These are the sense terminals. If these aren't connected, the unit will not know what it's doing. So I can also tap, if I wanted to do 4-wire measurement, I have 2 power taps for the positives and the negatives, and then I have sense on the very outside. So I could run those around to my device under test, hook those up, and do 4-wire measurement at the power input for the device under test. I'm not sure how I want to do that yet. I don't know if I want to put some really heavy gauge twisted pair wire in here and make some power studs that I can just connect devices to. Do that for the load as well as a couple of the others. I would like to get the other 2 Keithley power supplies, the 60 volt and the 32 volt 6 amp. This only goes to 20 volts. I would have liked it, especially with the battery simulation, to go a little bit higher, but my battery requirements are also kind of weird. So I don't know many people that work on 70, 80, and 100 volt kits regularly that aren't doing power grid scale stuff. So, but yeah, I would have liked to seen this to go up just a little bit higher in voltage. I mean, 20 is going to be fine, especially for the bench, but I'd love to see a battery simulator on a 60 volt or 72 volt power supply, because at 72 volts, that's 6 12 volt batteries. So that would be fun. But this is all I got, and the stuff that I need to do for my other half is all going to be button battery stuff. So it'll be well in this supplies wheelhouse to do. So sense terminals are hooked up, and we have power. Get this spun back around. And are we plugged in? Nope. Plug in real quick. That is one of the other things that I've done is for longevity of the screens. I'm turning them way down. I'm running them about 30% on the brightness. That way they're not just getting hammered, because even at 30%, they're nice and bright. I can read the 7510 all day long, the 6500 as well. So there we go. Okay, here's the first start. Now I have noticed the fan has kicked on already, and I've noticed the fan kind of ramp up over my air cleaner in the lab. So it is kind of loud being out here on the bench, but when I get it in its final resting place, which is going to be over on that side of the bench, I don't think it's going to be that much of a problem, because the fan is facing into sound foam, so it's blowing right into a sound absorbing material. So if I took the fans, like especially for that Liebert that I fixed in a previous video. That's a really, really loud fan, but when it's up against that, when it's up towards that sound foam, really cuts the. You guys can actually see it. It's back here. This is sound deadening material for the lab. Part of it was because I'm doing recording down here, so I have sound treatment. I've done solid sound treatment, which is excessive for a lot of people. Don't do solid. They'll put panels up, but it's solid all the way around the room to where the lab stops. So really cuts down the noise in here for recording. So, and for loud fans. So I'm not a good judge of fan noise just because of the way I've treated the room. So when we start the power supply, we have power supply, which is the normal power supply. We have battery test, which is to set this up so it'll help create a profile. You can create a profile with this unit, or you can create a profile with an SMU. I do have some SMUs on the to acquire list. So they will. I also want to add a couple of SMUs to the lab. Yep, I know they're expensive, but I am going to need them, especially when I do some capacitor leakage testing, because I'm working on a project where I need some extremely low leakage capacitors. So we'll see how that goes. It's just a matter of time. The reason the SMU is a little bit better to do the battery testing is because the SMU, I can adjust how fast the battery is pulled down. This will do it, and for like a AA battery, a D battery, something like that, this is fine, but it's fixed at 1 amp current draw. So when you hook battery terminal up to this, it is, when this is doing the battery testing, profiling, really, it's drawing an amp of current out of the battery. Not so bad when you're talking about lithium polymer cells, lithium ion cells, things like that. They can handle the current draw. It's not going to make a button battery very happy. So if you have to model like a CR2032 or something like that, those aren't designed to have an amp pulled out of them. The battery simulator, which is why I picked this up, so we'll go there first, actually models the ESR, the capacity, and the state of charge of the batteries. So what it does is, as I hook something up and I drain this down, it can also charge back up. So this can mimic a battery. Like if I'm working on a device with a battery management circuit where it's let's say a tablet. You throw a tablet. I have a tablet open on the bench. If I want to check the charge circuit, I can set this battery at half capacity, and then I can plug the USB key or the USB cable into the tablet, and it'll charge the power supply, and the power supply will dynamically change itself to act like a charging battery and then a discharging battery. You also need to, all you do, and let's see, menu, battery. Let's see what it comes with. Enter. Let's see. Nickel metal hydride, NiCad, lead acid, nickel metal hydride. What else do we have? Lead acid, NiCad, nickel metal, and lithium ion. 9, 8, 7, 6, 5, 4, 3, 2. Yeah, so it's got a couple of. I need to get some alkalins in here. So these have some rechargeable batteries. I also want to get some primary cells in here, but I'm going to have to sacrifice a primary cell for those. So what I'm going to have to do is I'm going to have to set it up, let it test, let it build the profile. Now you can transfer them through USB. You can transfer them through the Ethernet. I'm sure that's one of the reasons why I want to Ethernet this thing, because then I can put battery profiles in and out, and then I'd also like to use the SMUs to profile the pack, some battery packs as opposed to single cells. The other thing that I need to do is with the SMUs, you can model the batteries at other than 1 amp of current. So if I knew my device was going to draw like 100 milliamps or something like that, I could set the SMU, I could profile at 100 milliamps, and then I could use that as the model. This particular power supply is capable of adding up to 100 ohms of ESR into the output. So it can model a very dead battery. It can model a very fresh battery, and it can dynamically change the ESR based on state of charge. So it's voltage open circuit, state of charge, capacity, and then ESR of the battery. And then this is current limit, and yeah, VOC is voltage open circuit, current limit. I need to figure out what VT is. Yeah, so all it is really is it's a list. So I could create a battery model just with a couple of data points. So at 100%, at 0% state of charge, it's what open circuit voltage and what ESR. That's all this does. So what it does is as it goes, it'll find where it is on the list and dynamically create itself between the two. That's all that the SMU generates when you hook a battery up to it, is just a list of capacity, open circuit voltage, and ESR. One thing that is a little weird on this, you cannot change the modes on this power supply without turning it off and turning it back on again. So once you fire it up and it's in a mode, you have to reset it to change the mode. Probably not going to be a big deal, because when I have it working on something, it'll be dedicated to that project, so I'm not going to be switching modes that much without turning it off and on anyway. So let's see what battery test looks like. Okay, so current limit is 100 milliamp, amp hour, watt hour. Yeah, it'll do watt hour, watt, resistance, and capacitance of the battery. Never run into where I've needed battery capacitance before. That's interesting. And then voltage and current on the terminals. So let's see. Turn this off again. Turn it back on. And now we'll do the power supply. And this is the power supply. If this wasn't the battery simulator, this is what it would just come up to. It would just be right here. So I had it 5 volt set and 100 milliamps. Just turn the output on, and we have 5 volts, and our current's dropping. Now this is saying 5.0003. Once the 7.5 is warmed up, we'll check and see how accurate that least significant digit is. I'd imagine it's probably going to be pretty close. This did specify, or this did get calibrated before it left Keithley, as with all their equipment. One thing to note up here, there is a warning on the top label. Batteries are hooked up positive to positive, negative to negative, not serialized. Serializing the batteries will cause some damage. I didn't even think about when I bought this unit, which is going to be really cool. This unit can also duplicate supercapacitors. So it even calls out up here testing batteries and supercaps. So that will be very cool. I got to find some button battery profiles, because that's one of the things that I need this unit for. Hopefully I don't need an SMU tomorrow, because I still got a couple more payments on this. One other thing is that I do appreciate with Keithley is I'm trying to be a fan of blue LEDs. This blue is actually real dark. It's showing up a lot lighter in the camera, but it's a nice dark blue. I have some speakers. They're BX5As, and they have a blue LED in the front of them. And My wife and I have nicknamed it eye-searingly blue because I can't even look at it. It hurts my eyes. This is a nice, soft... It's a deep blue, but it's a nice, soft blue. It's not... It doesn't hurt to look at it. So that's one thing to be careful. I was playing around with one of the curve tracers, and I put in blue LEDs because I thought it would look cool, and I got the wrong blue LEDs in there, and it was awful. I couldn't even read the number. So this isn't a bad blue. Well, this is nice. The display itself actually turns completely off, just doesn't go dim. So 5.0003, I have it set to currently an hour dim out. Meter says our peak to peak was 80 microvolts, 5.003, so unregulated or unregulating works nicely. So let's hook up a load and see if the regulation changes. We'll ask it to give us about 3 amps because we'll be able to do that. Okay, I've set the unit to 5 volts at 3.25 amps. I gave it 0.25 amps because I wanted it to have a little bit of overhead. I'm going to tell the load I want 3, and then since it's loaded, I'll reset the counter on the 7510, let that run a little while. The wire is just some 14 gauge Romex that I had left over from wiring the lab. Most of the lab's done on 12 gauge. 14 gauge did fit in the pins right there. So what we'll do is we'll ask for an amp to start. On with the load. The regulation is real good. The voltage drop on the cable is about 500 millivolts. So it says 0.3, it's at 4.9, so 400 millivolts. We'll give it another. Here we go, 3 amps. That actually agrees with the load because the load says 2.999. That says 2.998. So that's good. We are getting some voltage drop. I'm not seeing 5.0003 anymore. I'm seeing 4.9987 and 4.832 on the load. Let me reset the statistics on the DMM, and we will just let that sit and run for a while. See how loud this fan gets. I have no idea, but that will be right boring. So I'm going to pause the camera and just let this do its thing. Okay, we've had the power supply running for a while. Doing a cool 3 amps. Move over to the meter. Check the regulation. 300 microvolts peak to peak. Standard deviation is only 30 microvolts with 737 readings. So not bad for a precision power supply. Looks good. So I'm going to get him hooked up over there on the bench. And that will be it. Thanks for stopping by the lab today and taking a look at the first looks on the 2281S 20 volt 6 amp power supply. I'm going to get a lot of use out of this. We're going to use it in a lot of future videos. So welcome addition to the lab. The power supply that left, because there was two of these 343s. I pulled the 343A to make room for the 2281. I'd also like to get the other two. I think they'll fit here and here. The 60 volt and the 6 amp one, the 32 volt. The non-battery simulators, they have a 60 volt. I think it's 3 amp and a 30 volt 6 amp, if I remember the specs correctly. So I know for sure I'd like to add the 60 volt one to the lab. Not sure about the 30. The 30 might have a lot of overlap with the Rigel and the 2881. But just some future plans. Might happen, might not, don't know. Have to see where the projects lead. But thanks for checking out the video, and I will see you in the next one.